So, last class I have solved a problem of plate load test. So, and I determine the value of allowable bearing pressure or allowable bearing capacity of foundation based on the plate load test data. So, now in this class I will discuss the other method by which we can determine the settlement of foundation resting on granular material. So, the next method by which we can determine the settlement is based on the SPT value or standard penetration test value. So, this is the IS code chart which we can use. So, this chart is from IS 8009 part 1 1976. So, here we can see that this is the N value, different N value starting from 5 to 60, and this is the width of the footing. So, x axis is the width of footing, these charts are for different N value, and the y axis is the settlement in meter per unit pressure in terms of kg per centimeter square. So, which means that if suppose we have a footing width, if say footing width is 3 meter and N value is say 15 is the N value, corrected N value, this is N corrected. So, what will be the, so this is the 3, this is the 15 N value chart. So, this is the 3 corresponding to this one. So, this value is equal to 2 into 10 to the power minus 2. Okay. So, this is in the log scale, the y axis is in the log scale. So, this is in a semi log graph. So, so that means we can say that our settlement will be equal to 2 into 10 to the power minus 2 meter per kg per centimeter square. Okay. So, it is in terms of, so if you multiply it is by 1000, so it will be 20 millimeter per kg per centimeter. So, this per kg per centimeter is the load intensity. So, now if you have if your say loading intensity of the foundation is 1 kg per centimeter square or 100 kilonewton per centimeter meter square, then your total settlement will be 20 millimeter. If your loading intensity, suppose if the loading intensity is 2 kg per centimeter square or 200 kilonewton per meter square, then the settlement will be 20 into 2, 40 millimeter. So, this is where we can use this chart, and another thing is that here also I can use the water table effect. So, we can use this chart, remember that here this is W dash, and again the actual settlement is settlement computed from SPT value divided by correction factor W dash. W dash is D by B, B is the width of the footing and D is measured from the base of the footing. So, similar to again if it is D is 0, then this is 0.5. If D is 0, 0.5, so that means this chart is similar to others IS code value. That means if your water table is at the base of the footing or above, then it is 0.5, and then it varies at B. If it is at the distance B from the base of the footing, then it is 1. So, it is in between 0, 0.5 to 1. So, and this W dash we can calculate. So, even the water table effect calculation also, the actual settlement will be the settlement that we are calculating from the SPT value and then divided by the correction factor. So, suppose if it is the base of the footing, as per IS code this correction factor is 0.5. So, if your settlement that you are calculating from the SPT value is 20 millimeter and the water table is at the base of the footing, then it will be 20 divided by 0.5. So, it will be 40 millimeter because of the effect of the water table. So, this is the water table effect, that also you can incorporate it, and this is the, we can use this chart to determine the settlement of the granular soil. So, next method, that is the based on SCPT, standard cone penetration test. So, the method is proposed by the De Beer and Martins 1957 first. So, where we can use this SCPT data to determine the settlement also. Say here what we have to do, we have to divide the our total soil below the foundation in number of layers. Okay? And then we such that the cone resistance of the SCPT cone resistance is more or less same on that layer, and then we calculate the compressibility coefficient C at the middle of each layer, and then we carry it out, and the effective burden overburden pressure at that means the cone resistance and the effective overburden pressure and the compressibility coefficient. So, compressibility coefficient, cone resistance and the effective overburden pressure we calculate as the middle of each layer, and then using this correlation or using this expression we can determine the H value. What is that? H is the thickness of each layer. So, then this will be the summation. If there is a number of layer, this will be the summation. So, this is 2.3 H by C. C is this the compressibility coefficient, and this C we can determine by using this correlation. Sigma B 0 or the that is or the P 0 bar is the effective overburden pressure at the middle of each layer, and sigma or delta sigma is the increment of the vertical stress at the middle of each layer due to the application of the external load. So, this is sigma 0 bar is the effective overburden pressure, and del sigma or the del P is the increment of stress due to the external load. So, and then Q C is the cone resistance that we will get from the SCPT value, and then if I use the Meharov suggestion, then this compressibility coefficient C is 1.9 Q C divided by sigma 0 bar, and whereas for previous method De Beer or Martin is given 1.5. So, this is the, as I was talking about, this is the these lines are the our QC variation of a particular soil, and then we are divided it number of layers, so that the average value is more or less same for all the layers. So, we are taking the average value where the variation is almost same. So, for all the layer and taking the average value. So, this is the actual cone resistance and then the average cone resistance that we are taking for each layer. So, this is the, and then we use these methods. And then the next one is the semi empirical method. This is provided by Buisman 1948, where it is similar to the previous method SCPT. So, difference is the here it is sigma 0 divided by E. So, initially it was C. So, this is the H is the thickness of each layer, and again sigma delta sigma is the increase in vertical stress at the middle of each layer due to the application of the external load, and E is the elastic modulus of the each layer, and sigma 0 bar as usual the initial effective overburden pressure. So, now if I summarize all the settlement calculations method that till now we have discussed, that if I categorize it for the clay and for the sand. So, immediate settlement I can calculate for the clay by using these expression, that immediate settlement calculation, and the consolidation settlement I can use these expression or this expression depending upon the availability of the parameter. This is for the clay. But for the settlement calculation for granular soil or the sandy soil, where all the settlement are immediate settlement, we can use these 4 methods depending upon the availability of the values. So, we can use the plate load test, we can use the SPT chart, we can use the SCPT value, we can use the semi empirical method. So, this is the expression for the semi empirical method. Here also this is the summation, and this is for C value calculation. Either we can use the De Beer and Martin's approach, or we can use the Meyerhof approach. So, so either these two we can approach, these two approach we can use. So, these are the total summary of this method. So, now first I will solve a problem where I will calculate the settlement immediate and the consolidation settlement of a foundation, of a wrap foundation resting on a clay. So, the problem definition is that the example problem is that we have a wrapped foundation okay, our dimension is 10 cross 15 meter square. So, that means the 10 meter, B is the 10 meter and L is equal to 15 meter. Okay. So, now this is our ground surface, this is the GL or the ground level, and it has the two soil layer system that we are considering. This is my layer 1, this is the layer 2, and this is the minus 19 meter, and this layer is minus 7 meter, and this is the 0 meter. Okay. Now, the water table is at 2.5 meter below the ground surface. So, this is the water table which is minus 2.5 meter below the ground surface. Now, properties that are given, that unit weight of the soil is 18 kilonewton per meter cube, and Cu undrained cohesion is 35 kilonewton per meter square, and Cc by 1 plus E0, because this term will be required for settlement calculation, is 0.06. So, Cc and E0 that will be determined by the consolidation test, and so that means here we will get the Cc compression index E0, and this layer 2, this unit weight is 17 kilonewton per meter cube, Cu undrained cohesion is 20 kilonewton per meter square, and Cc 1 plus E0 is equal to 0.15, and the depth of foundation df is also 2.5 meter. So, the depth of foundation is here. So, this is the raft. So, this is the raft where we are applying this stress, and this is 10 meter. Okay. And the intensity of loading, that Q net, the net stress is applied is 50 kilonewton per meter square. Now, calculate what is the total settlement. Settlement of the foundation. So, that we have to calculate. Now, the first I will calculate the immediate settlement, and the second I will calculate the consolidation settlement. The first one is the immediate settlement. Okay. So, now the Q net N is 50 kilonewton meter square, B is equal to 10 meter, and we need the values a Poisson ratio. In the clay, the Poisson ratio is, if it is undrained condition, the Poisson ratio, the range I have given in the table. So, that from here I am taking the K value, Poisson ratio value is 0.5. And in the problem that will be given in the assignment and the exam, this Poisson ratio value will be given. So, Poisson ratio, and the elastic modulus is taken as 700 Cu. So, in the normally considered range, this value is around 750 to 1200 Cu, the table that I have given. So, here I am taking 700 Cu. If nothing is mentioned, you can take from that range, or most of the cases I will mention this E value, whether it is 700 or 750 Cu. Here it is mentioned 700 Cu. And then the another thing is also mentioned, the A value, the pour water parameter is also mentioned, is 0.6, because this pour water parameter will be required A for the correction of pour water pressure. So, this is the value. Now, the Cu1 first layer is 35 kilonewton per meter square, Cu2 is 20 kilonewton per meter square. Okay. So, it is a layered soil, and I have mentioned for the settlement calculation my influence zone that I will take is twice the width of the footing. Okay. So, now my influence zone, because here it is the bedrock or the rigid. So, this is the rigid. So, this sign indicates, this bedrock indicates there will be no settlement for this soil or this material. The settlement will be only for this soil, which is from 0 to 19 meter. So, the influence zone is twice B, B is the 10 meter. So, influence zone will be 20 meter below the base of the footing. So, but this base of the footing, this distance is 19, this is really 16.5 meter only, because so that means we have to restrict this zone within 16.5 meter, because this is the bedrock which is within the influence zone, and we are assuming that this bedrock, this material will not deform, and so the deformation will be for the clay only. So, remember that if there is any bedrock or the rigid material within this clay layer, then you have to take the influence zone up to that bedrock or the rigid layer only, okay, even if it is less than 2B, because here the 16.5 which is less than 2B, but still as it is bedrock we have to consider up to 16.5. So, that means here 16.5. So, my your E value, E average, as I mentioned, you have to take the average, weighted average. So, here we are doing the Cu weighted average. So, in the other way we are doing the E weighted average. So, weighted average that we are doing, that for the E1 it is 700 into Cu1. So, that is equal to 700 into 35. So, that is 24500 kilonewton per meter square, and E2 is equal to 700 into Cu2, that is 700 into 20, because your Cu value is 20. So, this is 14000 kilonewton per meter square. So, weighted E average is 24500 into that one is this thickness of this layer is 4.5 meter, and this thickness is 12 meter. Yes. So, this will be 4.5 plus 14,000 into 12. So, divided by total 16.5. So, this value is equal to 16864 kilonewton per meter square. So, this is the your E average. So, now my immediate settlement. So, that is equal to this Q n into B divided by E 1 minus mu square into IF. Okay. So, the IF value for L by B, so here Qn is 50, then B is 10, weighted average that we are taking is 16864, mu is taken 1 minus 0.5 square and IF value is 1.36. This is from the table where L by B is equal to 15 by 10 into 1.5. So, from the table corresponding to L by B that I have given. So, corresponding to L by B 1.5, I am taking the IF value of the center of flexible footing. Remember that. So, I am designing the raft foundation which is rigid, but the IF value I am taking of the for corresponding to L by B 1.5, the IF value at the center of flexible foundation. Okay, because later on we will apply the rigidity correction. So, the final value of this settlement or the SI will be equal to 30.24 millimeter. So, this is the immediate settlement without any corrections. Now, as I mentioned, in the immediate settlement you have to apply two corrections. So, here it is a rigid footing. So, you have to apply rigidity correction and the depth correction. So, the next one that we will apply these corrections, and so our SI without correction is equal to 30.24 millimeter. So, we will get the rigidity correction which is 0.8 and the depth correction this is rigidity correction factor and depth correction factor is equal to 0.95. So, how I am getting? This is also from the chart. So, I have given the chart in the Fox correction chart. So, that from that chart I am getting this value. How I am getting this value? So, there is the need of D by DF or D by root LB. So, this is or D by root LB. So, D value is 2.5, L is 15 and B is 10. So, this is equal to 0.2. So, corresponding factor is equal to 0.95 and then L by B is equal to 1.5. So, corresponding factor is 0.95 we are getting from the chart. So, that you guys look at this chart, this from where I am getting this value. So, SI corrected will be equal to 30.24 into 0.8 into 0.95. So, that is equal to 23 millimeter. So, my immediate settlement is 23 millimeter after the correction. Okay. So, next one will be the consolidation settlement that we will get. This is the consolidation settlement. Okay. Now, this expression SC is summation of CC 1 plus E 0 H log 10 del P or I should first write P 0 bar or sigma 0 bar. This is P 0 bar plus del P divided by P 0 bar. Okay. Now, where I will use this thing. So, first if you look at this figure again. So, there is two layers, one is 4.5 meter, another is 12 meter. So, I will take a point the middle of each layer. So, this is the point A, this is the point B, middle of each layer, and the A point will be the 2.25 meter from the base, and B point is 6 meter from the base. Okay. So, this is 2.2 meter and this is 6 meter from not 6 meter from the base, 6 meter from the base of the first layer. Okay. So, now what I will do, I will calculate at point B, point A, my P 0 bar effective overburden pressure, and remember that here only one unit weight is given. So, that unit weight we will use as a saturated, I mean below the water table as well as the above the water table. So, that will, and if in some cases you will find two unit weight may be given, one is for the saturated and one is the soil above the water table. So, here one is given. So, that is why I will use both the cases the same water unit weight. So, that is why the P 0 bar effective overburden pressure at point A. So, above water table is 2.5 into 18, but below water table it is submerged. So, 18 minus 10, 10 you are taking unit weight of the water as 10. So, we are taking gamma W as 10 kilonewton per meter cube. So, and that is 2.25 from the base of the foundation. So, this will be 63 kilonewton per meter square. Next one, del P. How I calculate del P? Here del P I am calculating, suppose this is the width of the foundation B and where the 50 kilonewton is applied. Now, here I am assuming the load is distributing like this, and that distribution is, this is 1:2. Okay. So, now for at any height say Z, so what will be the stress at that point, because here it is 1:2 distribution. So, stress at that point, this is the del P additional stress will be, so del P will be equal to 50 into B into L divided by B plus Z divided by L plus Z. Okay. So, this is the distribution. Here you will find this is Z by 2. So, this one is nothing but, if this is 1 Z. So, this is 2, this is 1. So, if 2 is Z, this will be Z by 2. Similarly, this will be also Z by 2. Okay. So, that means here total stress will be 50 into B into L divided by B plus Z into L plus Z. So, similarly, for the length direction same thing will happen. Now, if I use these things, then our del P will be 50 into 10 into 15 divided by, it is 2.25 meter below the base. So, this will be 10 into 2.25 divided by 15 plus 2.25. So, this value is 35.5 kilonewton per meter square. Similarly, at point B, at point B, P 0 bar again will be 18 into 2.5, then now it is 4.5 is the thickness of this layer. So, 18 divided by 10 into 4.5, then it is 6 meter, then 17 is the unit weight, 17 divided by 10 into 6. So, this will be 123 kilonewton per meter square, and del P value will be again 50 into 10 into 15 divided by 10 plus, because it is from the base, that distance is 4.5 plus 6, that means it will be 10.5. So, this is 10.5. So, these things is coming 4.5 plus 6, that is 10.5 meter. So, and similarly L direction it will be 15 plus 10.5. So, this value will be 14.35 kilonewton per meter square. So, once I get this value, then I will get the SC, which is the summation. So, CC plus 1 plus E 0 for first layer thickness is 4.5, then into log 10, P 0 bar is 60, this value is 63 is P 0 bar and 35.5. So, this is 63 plus 35.5 divided by 63, then plus for the second layer is 0.15 into 12 is the thickness of the layer into log 10, 123 plus 14.35 divided by 123. So, this value is given 138.7 millimeter. Okay. Now, the corrections, again the rigidity correction factor is 0.8, then B is the depth correction factor which is 0.95, and then is the pore water correction factor, which we are getting 0.81. How we are getting? That is also from the chart. Okay? And from the chart we have A is equal to 0.6, and there is a term H T divided by B. H T is the soil below the influence zone of the soil below the base of the foundation. Here H T value is total soil thickness below the foundation, the soil zone is 16.5 and B is 10 meters. So, it is 1.65, and as in that chart you will find there is a for circular footing or square footing and for strip footing. So, here the value here your L by B is equal to 1.5, which is neither circular nor square nor the strip. So, here I have used the strip footing, this is for the strip footing expression, strip footing value, that is giving 0.81. But if you want, you can take the strip footing value and the square footing value, then you can linearly interpolate this value for 1.5, because for the strip footing your B by L is equal to 0, and for square footing is equal to B by L is equal to 1, but here present case it is L by B by L is 10 divided by 15. So, what you can get, you corresponding to this value, you take the strip footing and the square footing, then really linearly interpolate this value in between them. So, that way also you can calculate, but here I am directly using the strip footing value calculation, because that will give you more or less the close value. So, now the corrected SC is 138.7 into 0.8 into 0.95 into 0.81. So, that is equal to 85.38 millimeter. Okay. So, the total settlement is immediate plus consolidation settlement. So, immediate is 23 plus consolidation settlement is 85.38. So, total one is 108.38 millimeter, or it is close to 108.4 millimeter. So, that is the total settlement is calculated for this raft foundation resting on the clay. So, in the next class I will solve a problem where I will determine the settlement of a foundation which is resting on a granular soil. Okay, because here it is on the clay and we have discussed these two methodologies for the immediate settlement and the consolidation settlement. Next class I will discuss the settlement calculation of a foundation on resting on sand, and then I will discuss the based on the available parameters or sand properties, which method, because we have discussed there are 4 methods available based on the for the granular soil, plate load test, based on the SPT value, based on the SCPT value, and some semi empirical expression. So, out of these 4, which one we will use? So, we will decide depending upon the available soil properties. Thank you.